Hello students, welcome to today's session of chemistry. As you all know, we have started studying 8th lesson of your syllabus, that is transition and inner transition elements. We call them D block elements and A block elements. Of these two types, we have started studying D block elements, or we call them transition elements. In the previous sessions, we learned about the position of D block in the periodic table, the electronic configuration shown by these elements, the variety of or variable oxidation states shown by these elements, their physical properties. And in the previous session, we started studying about the periodic trends shown by these elements concerned with some atomic properties, out of which we learned about atomic and ionic radii, ionization enthalpy, and a metallic character. We will just revise that. So, atomic and ionic radii, we learned that moving across a period from left to right, atomic as well as ionic radii decreases. In the same way, about ionization enthalpy, we came to know that the values of ionization enthalpy are in between that of S block and P block elements. S block has comparatively low ionization enthalpy values, while P block has higher ionization enthalpy values. But these elements, as they are located in between S and P block, the values are also in between that of S block and P block. So, this much we learned in the previous sessions. Now, in this session, we are going to learn about three more properties, that is magnetic property, color, and catalytic property. Let us start. First property we are going to study about these elements is magnetic property, or the elements show magnetic properties. The compounds of transition metals, they show they exhibit magnetic properties because of the presence of unpaired electrons present in their atoms or ions. The reason for these three properties basically is presence of unpaired electrons. Why there are more number of unpaired electrons in D block elements? Because as we know, in D block, D subshell is completed, and D subshell has 5 different orbitals. That means they have capacity to accommodate 10 electrons. But according to Hund's rule, all these orbitals are first singly occupied, and then the pairing starts. Hence, all the orbitals they get singly occupied, and the pairing starts when the orbital first all the orbitals are fulfilled with single electron. That means when 5 orbitals get 1 electron, then sixth electron enters first orbital. Because of this, the orbital has more number of unpaired electrons, and because of unpaired electrons, they show magnetic property as well. Now, what is magnetic property? When a magnetic field is applied, substances which are attracted towards that applied magnetic field are called paramagnetic. The substances which are repelled towards that applied magnetic field are called diamagnetic, and some substances are attracted very strongly, and those are called ferromagnetic substances. So all these properties are shown by D block elements. They, this block particularly contains some ferromagnetic substances as well. For example, iron, cobalt, nickel. If you remember, these elements are located at the center of the transition series. That means they contain a maximum unpaired electrons, and hence they are ferromagnetic. They strongly get attracted in a magnetic field. When magnetic field, it is applied externally. What happens? These all unpaired electrons, they align in the direction of applied magnetic field. Hence, their spin, that the spin of these electrons, that remains unbalanced, because all these electrons, they align in the single direction, hence they show same spin. And when an orbital, it gets two electrons, they are always of opposite spin. But as all the unpaired electrons show same spin, an angular momentum is developed and the magnetic property is enhanced or increased, and these metals can be easily magnetized, or they acquire permanent magnetic moment because the number of unpaired electrons is more. Each unpaired electron gives rise to a small magnetic field around it, that is called as magnetic moment because of its spin. Angular momentum or orbital angular momentum is developed. This magnetic moment can be calculated using spin only formula. It is shown by a letter mu, and the formula is mu equal to under root n into bracket n plus 2 bm. Bm is unit Bohr magneton, and n, small n, is the number of unpaired electrons. Mu is the magnetic moment. A single unpaired electron also has a magnetic moment, and it has the value 1.73 bm. And this value of mu vary directly with the number of unpaired electrons. That means it increases with increased number of unpaired electrons. It actually gets, when the number becomes double, the value becomes double. And if the number is triple, the value becomes triple. Hence, we can easily calculate number of unpaired electrons by using spin only formula if magnetic moment of the metal complexes of the first transition elements are known. So, understood this? There may be a question asked for 1 mark. Find out the n, or number of unpaired electrons, or sometimes to calculate mu. So, this is all about magnetic property. Now, second property is color. When the substance appears colored, do you know that? When it absorbs a portion of visible light. The color depends upon the wavelength of absorption in the visible region of electromagnetic radiation. That means color appears when it absorbs the color of certain wavelength from the visible region of electromagnetic radiation. The transition elements show both the types of compounds, ionic as well as covalent compound, and all these compounds are colored. The color of a transition metal ion is because of the first and most important reason is presence of unpaired d electrons. These d electrons show dd transition. That means I told you that d subshell has 5 orbitals. If any of the vacant orbital is available, then these d electrons, they get excited to that vacant orbital because all these orbitals have same energy, and hence dd transitions are easily possible. Third reason is the nature of ligands attached to the metal ion. What is ligand? These transition elements have a tendency to form coordination compounds, or these are complexes actually. The central metal ion gets attached with some atoms or ions. by coordination bonds, and that is called as ligand. That atom or ion which is attached to central metal atom are called ligands, and because of this a complex is formed, and the geometry of that complex formed by this metal ion, that is also responsible to give color to that substance or the complex. Now, transition elements, they have unpaired electrons in their d orbitals. When this atom is free or it is single or isolated, then these 5 orbitals, they have same energy. I told you, those are called degenerate orbitals because all orbitals are in the d subshell itself. They are almost similar in their energies. Hence, dd transition, that means excitation of electron from one d orbital to another d orbital, is easy because it requires very little energy. So, the energy for the transition of electron from one d orbital to another is quite small. This small energy can be made available by absorption of radiation having certain wavelength from the visible region, and remaining light is transmitted, and hence the observed color of that compound corresponds to the complementary color of light absorbed. Understood? Because of dd transition it is possible. Very less energy is required for dd transition, and that energy is absorbed from the visible region, and hence remaining light is transmitted, and that gives color to that compound. What happens if there are no unpaired electrons? Then that compound remains colorless. For example, copper Cu plus ion. It has 10 electrons in 3D subshell. All the orbitals contain paired electrons, hence it is colorless. In the same way, titanium plus 4, that means all the 4 electrons in the last subshell are donated, and hence it has 0 electrons in the d subshell, hence it is also colorless. Understood? If there are no unpaired electrons, the compound will be colorless. So this is all about color. Now third property is a catalytic property. That means the transition metals and their compounds exhibit good catalytic property. That means many of the compounds formed from D block metals, they are used as catalyst. They can be used in both type of catalysis it is actually, homogeneous as well as heterogeneous catalysis. They have the ability to participate in different oxidation reduction steps of catalytic reactions. These steps involve changes in the oxidation states of these metal ions. For example, suppose any reaction it has 2 or 3 steps. Out of these 3 steps, suppose one of the step is oxidation or reduction. How it is understood that it is oxidation or reduction? If the oxidation state is increased while going from reactant to product, then it is called oxidation. And if the oxidation state is decreased while going from reactant to product, it is called reduction. And suppose in a process, suppose one of the reaction is oxidation or reduction, in that reaction also, these element and their compound, they act as catalyst. The compounds of iron, cobalt, nickel, palladium, platinum, chromium, etc. are used as catalysts in number of reactions. What they do? As we always make a definition of catalyst as the one which excites or which accelerates, enhances the rate of reaction without taking part in the reaction. So these compounds of these elements also, they prove the definition. That means they can be used as catalyst. Now, what is homogeneous and heterogeneous catalysis reactions? Homogeneous the metal ions participate by forming unstable intermediates. Actually, homogeneous catalysis means when the reactant as well as catalyst are in the same state. For example, reactants are in liquid state and the catalyst also in liquid state. That is called as homogeneous catalysis reaction. In these type of reactions, these metal ions of D block, they participate by forming unstable intermediates. What does it mean? When reactants get converted into product, we only see reactant and products. But what happens is these catalysts, they form a complex intermediate between reactant and product. That intermediate exists for very little time, but that converts reactant into product. Hence, it is not observed in product. So, this type of, that means it has a definition, it doesn't participate in the reaction, we say, but it actually participates. But while forming part product, it gets removed from there. Hence, this type of catalysis is a homogeneous catalysis. What is heterogeneous catalysis reaction? In this type of reaction, that metal provides a surface for the reactants to react. Actually, heterogeneous catalysis means when the reactant and catalyst are in different states. For example, we have seen hydrogenation reaction where hydrogen gas reacts with alkene, ethene, for example, and nickel, which is in solid state, is used as catalyst. It provides its surface, or hydrogen gas is adsorbed on the surface of nickel and it brings about the hydrogenation. That means it converts ethene into ethane. Such type of reactions are called heterogeneous reaction, where metal provides a surface for the reactants to react. So this is catalytic activity of D block elements. We will take some examples. For example, manganese dioxide acts as a catalyst for decomposition of potassium chlorate. In the same way, we have seen the manufacture of ammonia, that is NH3 from nitrogen and hydrogen. Both are gases. At that time, molybdenum and iron is used as a catalyst. It is example of heterogeneous catalysis reaction. In the same way, cobalt thorium alloys is also used in Fischer-Tropsch process, which is used for synthesis of gasoline. In the same way, this is the example I have told just now, conversion of ethene into ethane by using nickel as a catalyst, which the hydrogen gas is adsorbed on the surface of nickel and reacted with ethylene and converted to ethane. This hydrogenation process by using nickel as a catalyst is very important commercially for the preparation of margarine from inedible oils. Inedible oils, they contain unsaturated fats. By using hydrogen gas, they are converted into saturated fats and that we call vanaspati ghee or margarine. In the same way, we learned contact process for the manufacture of sulfuric acid. One of the steps involved in this process is conversion of sulfur dioxide by using oxygen to sulfur trioxide. In that process, platinized asbestos is used as a catalyst. So these are the few examples where these elements or D block elements are used as catalysts. Understood? So now the time for assignment. Give some examples of heterogeneous catalysis proving D block elements can be used as catalyst, particularly heterogeneous catalysis I want. Again, considering a first property, that is magnetic property, define paramagnetism, diamagnetism and ferromagnetism, as well as give the spin only formula for what purpose it is used. Understood? Now, the second property is color. So, explain the property shown by D block elements, and the property is color. Explain the color property shown by D block elements. You can write like answers of these three questions in a separate notebook. So, thank you.